Well, good afternoon, everyone, and good morning to some of you. Today, sorry for such a long delay. We just had a few issues, and it really was an issue with using Google Chrome. We did not know that. So, further future reference, if you're using Google Chrome, the extensions Adobe Connect doesn't work so great with it. But today, we are going to be having Aquaponics paradigm shifts with Airlift. This is part one of a series of Aquaponics webinars that Benny will be doing for us. I don't want to waste too much time with an introduction since we wasted some already. I'm putting up a link in the chat box right now. This is for the survey to take after this presentation to get us some feedback on, basically a lot of feedback on how valuable you find these webinars and what we can do with our webinars in the future. So feedback is very, very important to us. So please participate in this survey. And without further ado, Benny, it's all on you.
Aloha, everybody. Sorry again. I wasn't aware that I cannot work with the Chrome and I need to work with Firefox. It is a pleasure to work with Vanessa on that. And at last we can go on the extension and talk about the aquaponics paradigm shift with Airlift. I look at this, especially with the time limits, that it's going to be more an inspirational, I would say, kind of talk for this time, and I'm planning already to have much more detailed on how to for the next presentation. So we'll have the real measurements and we'll give you some numbers how to work with and how to build your Airlift. Just to give you a little bit background, I'm an aquaculture specialist, extension and training at Human Nutrition, Food and Animal Science Department at College of Tropical Agriculture Human Resources at the University of Hawaii, Manoa. Just to let you know, not long ago I was the aquaculture program coordinator at the Office of the Vice Chancellor here at the University of Hawaii. Before that, I was department head of genetics and physiology in the National Center for Mariculture in the Oceanographic Institute in Israel. Before that, department head of physiology. And a visiting professor at the Hebrew University and Ben-Gurion Universities in Israel. To give you some background, I developed at the University of Hawaii the Aquaculture Hub that some of you may know, and this is then with the help of Professor Barbara McLean, I developed also the A2 program, the Aquaculture training online learning, and you have the links in case you're interested. This seminar, this webinar, actually is sponsored and with a lot of work and good help from Vanessa Weldon. And this is just, I put some a little bit information about the extension. And of course, you can always contact with Vanessa and she will help you more on how to use the extension and get all the benefits of it. Why actually we started with Airlift pump? Actually, this was kind of inspiration as part of my trips to the Pacific as an extension and to help people with aquaponics. In one of those trips, I assembled a team, and in the team was Glenn Martinez, who is the owner of Olomana Garden, and he's very known for his passion to work on and improve aquaponic systems and to spread it around the world. I also went with him to the Philippines, and right now we have a fabulous system there feeding a big school of 900 kids, and there are more of those examples that we did around Philippines. And in American Samoa, we realized we have some problems. This is with the guys in American Samoa, some of them at least, and you can see on the far end on the left, actually the first Airlift system that we assembled over there because of the need that we had there. We had to draw water from below the ground into our aquaponic system because of the kind of very narrow and deep tanks that were given to us to have the fish in. To put a water pump, it would be a problem, both of problem related to the depth and related to the fact that in American Samoa, we were requested basically not to work with those pumps because they might be stolen. So we had to solve another problem, is to have the pump at home next to the TV and have the pump working 50 yards away from it and drawing the water onto the aquaponic and vegetable beds. So how do we do that? And this is where we started with that. You can see in the picture on the far left, as I said, it's the part of the air pump, airlift pump, and then you can see me. Behind me is Ephraim Temple, the extension person for Seagrant in Samoa, and then Troy, and then we see Natalie Cash, who is the manager of the Olomana Garden, and behind her, Glenn Martinez, running this, helping me with this workshop, and we did some interesting stuff. So let's go, first of all, to explain what is an airlift pump, because I think many people are trying to go into it, and I feel the need, at least in this presentation, to give you some basic, including the physics, and I'm sorry if it's a lot of explanation and not too many pictures. So the airlift pump is a gas lift pump which is powered by compressed air. Airlifts are used in cases where light suction is needed. You can see some of the literature on it, and I would like to mention that if you have the book by Timmons and Evelyn on recirculating aquaculture, second edition, you can find about the airlift in page 553. Although there's not much written about that, from the visit that Timmons have had here in Hawaii and visited Olomana Garden, it seems that we can accomplish now doing more efficient things. Now, the inventor was a German guy, Karl Emanuel Loscher, and it seems that it was invented 1797, relatively not long ago. The principle by which airlift pump is operating, we need to take in consideration that only energy required provided by the compressor. So the airlift pump, the principle is like energy is by compressed air, and this air is usually compressed by a compressor or blower, and it's injected in the lower part of a pipe that transports a liquid. For us, is water. It usually bubbles into another larger diameter pipe. By the buoyancy, the air, which has lower density than the liquid, rises quickly. By the fluid pressure, the liquid is taken in ascendant airflow and moves in the same direction as the air. The calculations of the volume flow of the liquid is possible thanks to physics of two-phase flow. And the airlift pump technology is superb due to its simple structure. We have to remember that when we talk about airlift, we are having two-phase, and I will explain about that right after. We have to remember that gravity is playing an important role. Bubble wants to go out, and gravity is something that you need to think how it plays in this matter. Now, if we're going to move to the two-phase flow, what we know that in fluid mechanics, two-phase flow occurs in system containing gas and liquid, which a meniscus separating the two phases. Two-phase flow is a particular example of multi-phase flow. What we're going to have here is give you some examples. Just to let you know, historically, probably the most common studied cases of two-phase flow are in large-scale power systems. Coal and gas-fired power stations use very large boilers to produce steam for use in turbines. In such cases, pressurized water is passed through heated pipes, and it changes to steam as it moves through the pipe, The design of boilers requires a detailed understanding of two-phase flow heat transfer and pressure draw behavior, which is significantly different from the single-phase case. Even more critically, we have it in nuclear reactors, use water to remove heat from the reactor core using two-phase flow. A great deal of study has been performed on the nature of two-phase flow in such cases so that engineers can design against possible failure in pipework, loss pressure, and so on. A loss of coolant accident is a major thing. Another case where two-phase flow can occur is in pump cavitation, where a pump is operating close to the vapor pressure of the fluid being pumped. If pressure drops further, which can happen locally near the veins of the pump, for example, then a phase change can occur and gas will be present in the pump. Similar effect can also occur in marine propellers. Wherever it occurs, it is a serious problem for the designers. When the vapor bubble collapses, it can produce very large pressure spikes, which over time will cause damage on the propeller or turbine. So, the two-phase cases are for single fluid occurring by itself as two different phases, such as steam and water. The term two-phase flow is also applied to mixture of different fluids having different phases, such as air and water or oil and natural gas. So let's look at what I'm talking about: bubbles, rain, waves, sea foam. All these are examples of two-phase. Interesting example is that when people do excavation from the ocean floor in archaeology and etc., it's been used extensively. But it might cause some problems, such as weak suction, unstable flow rate, frequent clogging, difficult flow control, and low lift. Example, an application, as I said, I mentioned it already, that it can be in coal and gas and nuclear reactors. Now let's mention the disadvantages. Above the others that I mentioned is the cost, and this can be quantity of air to compress in high compared to liquid flow required. Conventional airlift pumps have a flow rate that is very limited. Pumps is either on or off. This is something we need to take in consideration. And suction, as I said, limited, and pumping system is suitable only if head is relatively low. And we have ways to overcome this. And because of this principle, a lot of air remains in the liquid. However, as mentioned also by Timmons and Abling, with thoughtful design, appropriate maintenance, and effective management, airlift pumps may allow the transfer of water through an aquaponics system in a more efficient way than using pumps. Understanding the disadvantage and learning how easy it is to construct an airlift pump can help many to reduce their energy cost while avoiding the high risk and maintenance resulting from having submerged electrical pump in the fish tank. So the pump itself, if it's an air pump, basically all we need is an air pump. It's very reliable. And because it sits outside the water, there's not a problem to have this air pump staying there for a long time without any problem and without getting rust or anything like that. It also acts as a water aerator and can, in some configuration, lift stagnant bottom water to the surface, and by that we are avoided from anaerobic layers and problems. And especially it's very important in the aquaponics system because we want to mix the water well. There are some improvements. In 2007, they invented the geyser pump, and this pump can have a greater section and less air. It also pumps proportionally to the airflow, permitting use in the process that require varying control flows. So basically what we do here, we create some large bubbles that accumulate, and then they all jump at once, and they have the power to lift up and raise a large amount of water at once. And people used to use it for slug fluid, and from really dirty areas in waste treatment plants. And we also sometimes, because of the sound, we call it the burp pump, because it has those sound when the air is released from the system into the air. Now we see here an example of how the simple way that it works. Basically, and I will explain a little bit also about the two-phase here. So basically what we see here, we see a tank with water, and then we see an air source, number one, if you can see, and we go with this, usually as we said, the tubing or the pipe that brings the air is smaller than the one that holds the water. The pipe, the water pipe is open, close to the bottom, and it's wider. And then the air is basically coming into a mixture with the water that's in the big pipe in the center. Now what we have here is a very interesting phenomenon, and that's where we talk about two-phase. We have basically in the big pipe in the center water, but the water is mixed with air. The water that is mixed with air is lighter than the water on the sides all around the pipe that's in the center. So gravity plays an important role because the heavy water in the tank is trying to displace the lighter water. And when this happens, basically the mixture of water and air in the center pipe is pushed out. In the next slide, we see some improvement, and we see the air source is coming into two different areas. And when we see it, it is two different areas, or it's basically building up bigger bubbles instead of those tiny bubbles. I will go back to the slide before. As you can see here, we have a mixture of tiny bubbles in the central pipe. And yes, you can call it also density, but the bottom line will be that the more dense water or the very dense water will be heavier than the mixture of the water and air, and therefore will try to displace it. So again, I'm coming into the improved Airlift pump. As you can see here the whole structure is built in such way that we're creating, instead of tiny bubbles, bigger bubbles, and those bigger bubbles, as you can see in the center, are pushing at once large amount of water. So this way, the power that comes out is greater. Now, this is taken from Timmons and Ablin, and that they're showing here, how this happened. And by the way, the nice thing about what they show here, and that's why I wanted to bring it to your attention, is that those bubbles start really small if you start from the bottom, but eventually, when they're going up along the middle pipe, the big pipe with the water, some of them are getting together and dissolve into each other to bigger pumps, and you basically have similar impact like we saw in the slide before, where they fill up the whole pipe and the water is locked in between the big bubbles, and this helps to push in a more forceful way the water out at the top. Over here you see three flow patterns. The idea here is, again, when we have tiny bubbles on the left versus bubbly slug and then the slug. And so basically when we create big bubbles eventually, they have the ability to push a heavier stuff at once. That's another variation of how people using the Airlift pump. And I'm going to show many more examples in my next presentation. And I wanted to let you know that on aquaculturehub.org, I'm building a special blog that will be, all the information will be available in much more details and many more movies and pictures, because the time is very limited, especially when we started very late, and I don't want to take too much of your time. So I'm going to give you an example of something that has been done in Olomana Garden. And as you can see, this looks like a very simple aquaponic system. When you see on the left, you see the tank, the fish tank, and then you see elevated on cinder blocks. We have the growing beds on the top with cinder in it. And if we go next, I'm just showing how the tank looks like. It's 180 gallons. And if we go to look inside, we can see what has been done in order to make sure that there will be a good flow into the pipe, which will lead into the growing beds. There are cuts into these 2-inch pipes, and it's if the advantage of this system is that if some of the areas are being clogged, the water can still go in eventually. And if you change the height, eventually, if you take the pipe all the way to the top of the tank, basically even if the water rises a little bit because it gets clogged on the bottom, eventually it finds this and slide in the right slot and slide in to a higher point, so the water flow continues. Now this is from the outside where we see how it's being connected and going out. And this is an important point here to show you. What we see here is a one-way valve. I don't have with me right now. We have also those valves, transparent valves, that are much more expensive, but we use them too to demonstrate how we're working with it. But this is a one-way valve. The good thing about it that the water and the air cannot go back. So even if you have the air on the left side being basically pumped into the mixture of water and air, it cannot go back into the tank. So it's going to be like one way, forcing the mixture of the air and the water forward. Now, as we can see along the pipe, and you can see that it's quite different from what you saw in the drawing that I showed you. Over here, we actually have a garden hose with the air coming from the air pump, and I will explain a little bit more about the idea of how we're using garden hose and why we're using it. Basically, it's right after the one-way valve coming in into the T, where you have 2-inch and 3/4, and the air is being pumped there. So the air cannot go to the right, where is the one-way valve. The air and water are going only to the left, towards the growing beds. Here is where the mixture of the bubbles, the air bubbles, and the water are coming into this T. And please notice that we have the T with a little cap on the bottom, and this is in purpose also to make sure that there is a good mixture And what's happening here also is that we start having the bigger bubbles that created, and we know that when the little bubbles are together, then it becomes stronger and pushing and locking the air in between them and pushing the water up the pipe. This is probably something you cannot really see too much, but I can tell you that what is created over here is a very interesting thing. The mixture of bubble and water coming up, and this is already above the growing beds. You can see in the background the black tub with a cinder. It's a little bit unfocused, but you can see that what you have here is this tea. Basically, the inside of the tea, something it's hard for you to see, we are adding a little pipe that is continuing to go all the way to about halfway within the 2-inch tea. This way, if there is water that is falling down because the air is continuing up and being released eventually, we actually trap the water right there. And so the water is being forced to go to the left into the transparent pipe that you see. So we create, in the way, traps for the water to make sure that once they go up, they can only go forward and they cannot slide back into where they came from. Now, making sure that we go way high above, and again, all these areas, what we can see, that we make sure that we trap the water and eventually slide them into the right direction. And the other thing is, over here, we also building like a muffler. The whole system with the Airlift pump is creating quite a noise. And that's why, I would say, Glenn and many others start calling it the burp pump, because it makes special noise when the air is coming out. And if you have it in a residential area, it might cause some problems with the neighbors. And we already know from our experience that it is the case. So one way to do it is to start building also a muffler to the system. And next time we talk about it, I will show you how to build a muffler to Airlift pumps. Now, this is going back a little bit and looking at the system. You can see on the far right, on the bottom, you see the fish tank. Then you see on the grass, on the bottom, next to the cinder blocks, you see the one-way valve. Then you can see how the one-way valve is going a little bit higher in purpose. And then we have the green hose, the garden hose, coming in, and this is where the air is being pumped inside the 2-inch pipe at the T over there. Then this mixture cannot go back because of the one-way valve. It continues forward, and then it starts climbing in a smaller diameter pipe. What we do, sometimes we have double pipes inside, so you cannot see the inside pipe if we use a 2-inch pipe. And we push the water all the way up. And what you can see, I don't know if you can see, right around, let's say, where the next tee that you can see. This tee, as I said, is unique because it has a water trap. So basically you have 1 inch coming inside and going a little bit more, actually halfway inside the 2-inch tee, which traps the water and doesn't allow it to go back. and then it goes into the back into the growing beds. You see here at the 2-inch pipes, and you can see the fittings, the elbow fittings, coming out, and you know it already. Some of you who do aquaponics, you know that the angle of those fittings is very important because it will decide how much water and many times also the flow of each of the trays that will go in and will affect the whole system and what's happening in each of the trays. Basically, that's what I wanted to show you. I realize we are really short in time, and I wanted to leave time for questions. And I wanted to make sure that you know that what we're going to have is this blog and more presentation and movies available for you on Aquaculture Hub. And I'm open for questions.
Okay, Benny, I see one from Kevin Gorham. It's when air is pumped in at the point in the system, why doesn't the pressure cause the check valve to shut?
Okay, that's a good question. What's happening when the air is pumped in, the water that's coming from the fish tank is quite heavy. And those water coming in 2-inch pipe, and they want to move forward. So this pressure by the water, and this is, as I said, this is where we talk about two phases. The water in the tank with the fish is much more dense, much more heavy. There's a lot of gravity on those water. The water push forward. So when they mix right away with the air, the moment the air is introduced into the water, two things happen. One, that mixture, what we call it the two-phase, right away is lighter and being pushed by the water coming from the fish tank. At the same time, the air is finding its way up on the pipe, the leading to the top, towards being released into the atmosphere, which that's what the air is would like to do. And you have to also see, if you can see also, there is a little bit elevation between the one-way valve and where the air is introduced. That means the air would like to stay on a higher elevation rather than to push back and go down. So you have all these things that I mentioned eventually causing the air or the mixture of air and water to go forward onto the leading pipe that you can see in the picture.
Thank you. We've got a couple more questions popping up. One is, what is the energy consumption? Do you have a calculation for gallons per minute per kilowatt hour?
Well, that's a good question, but what I can tell you is that, and this is one of the impressive things that we have, we are using pumps that are only between 35 or 38 watts, air pumps, to 60 watts, depending on how many gallons you want to push. And we realized, like, for example, we did it on a bigger operation. This is a really small, just to compare. We did it in a big shrimp farm in some tanks, and we used the 60 watts. And we were able to get something like over 600 gallons per hour. So that means during the day you can push about 14 to 15,000 gallons of water with 60 watts. I'm going to also, one of the things that I would like to share with you eventually, and this is where I'm going to put more information, and it will take time also to look at it and know how to use it. These are tables and Excel files for you to use, and just you plug the numbers and you can easily calculate for your own system how much you need.
That's great. Thank you. Let's see. The next question is this a pulsed air supply or constant air supply?
I say it again. There's a pulse air supply or okay. That's a good question. As I said, when the air is coming introduced into the water, we have tiny bubbles, and those tiny bubbles, when they start moving along the pipes with the water, they merge and they're creating bigger bubbles. And when you have big enough bubble to fill out the whole diameter of any given pipe that you have, they lock the water in between bubbles. Those big bubbles basically are separating the water. So when the water coming out onto the grow beds, it's going to be a little bit pulsatile. But if you can look at the top, what we have here, this transparent area after the 2-inch T at the top, if you create an opening and you can mixture it again, then it can come as a one flow. So basically, all these pipes that you saw going up high in the air is a great place for this mixture to climb up and then go down in a more, I would say, continuous flow rather than the barb, pulsatile.
Okay, Andrew
your question.
Ross asked, are you using a diaphragm check valve or a single swing?
Oh, you talk about the air pump, it's a diaphragm.
Okay. Yeah. Kevin Gorham, is there any issues with solid or waste accumulation at the point where the air and water mix?
Totally not. And very interesting what we do, and I don't have the picture here. I will make sure to publish them on the Aquaculture Hub. We take sometimes a whole bunch of leaves and we stick them at the entrance where's the fish tank. And it's amazing to see how it goes through the whole system and it goes through the one-way valve and then it climbs all the way up back onto eventually to the growing beds. Because actually, think about it, there are no moving parts or there is no pump in the water where leaves or gunk can get stuck inside. So the pump is totally outside the system. You can see only the garden hose connected to it. And all you have in the pipes is water and air. There are no moving parts. So we are taking a lot of effort to make sure that nothing gets stuck in the way. And I tell you, this system is really cool because we haven't had anything stuck in the pipes.
Oh, that's pretty good. Andrew Sloss, he said is there a check valve in the water line, and what type is it?
One on the water. Check valve? Oh, you're talking about on the bottom, in the grass? What we see in the grass, I'm not sure if this is what he's talking about, but let me go back. If you're talking about this one, this is a one-way valve.
I think that answers it. Yes, that is answering his question. Can you use this type of system to clean solid waste from a system?
Yes, definitely. If you remember, I will try to go all the way. I can go all the way back. I'm not sure we want to do that, but if you're going to go all the way back to, I'll show you something. That's really, if you look at this part, what we call it the geyser pump, it's being used for, human waste, treatment plants. And I can show you another picture real quick, and where actually you take sand. If you see this picture, the whole thing was, if you notice, there's a lot of sand is being basically sucked from the bottom of the ocean all the way up. This is for archaeology oh, I don't know if you ever saw the movie, I think it was called The Deep, where they were looking for some treasures and looking for some drugs or whatever, and they were going all the way down to the bottom of the sea in order to collect all the gunk that was there. And it's one of the best uses for airlift. So it will collect a lot of stuff from the bottom, and you can get a good mixture. So you can use it also as like a siphon if you want to.
All right. What height are you pumping up to?
Oh, that's a good question. Because the regular airlift pump principle is usually related to the height where the water level is, and compare, or from the height of the water level that you have in the tank to where you are starting to pump the air into the water mixture. So one of the innovation things that we are doing with Glenn Martinez, and he really became, a wizard on that, and I don't have here the picture. I'll make sure that next time I will show it, and I will put it also on Aquaculture Hub. He is able to use this system for over 30 feet high. So the principle is like that. If you want to bring the water higher than the tank that you're using, and I'm going to go real quick back to maybe the last picture so I can maybe explain more. If you want to bring the water really high, if you see, let me see over here. Yeah, if you will look at the bottom where you see the green hose is coming into the mix to mix with the water. If we will take all these things and we will bury it further down under the tank. So let's say I'm going to dig into the soil here, into the earth, and let's say I will go for 3 feet into the soil, and I will start the whole process from there. I can almost double the height that I'm pushing the water above the growing beds. So it appears that the deeper you start mixing the air with the water, the higher you can go up eventually with the water. We did an experiment with Glenn. We were able to take it to second floor.
That's actually really impressive. I don't see any other questions. There's a few people. People are pretty amazed. We've got a lot of thank yous. I'd like to thank you so much, Benny, for doing this. And I'm sure there's a lot of people. I know I am looking forward to part 2 of this series. Wait a minute. We got one more question. How does the burper compare to Glenn's other pump that channels air through the main pipe?
Well, the burper is coming in pulsatile manner, and that's why we call it, burper. But we also developed something like a little chamber. As I said, if you look at the top, when the pipe goes above, and you see the red holder to the growing beds, and above that you will see that from 1 inch it moves back into 2 inch, and it becomes wider. This area is basically a trap for the water. At the same time, the water continues to go up with a mixture of air and water to the point where the air is eventually released into the atmosphere. You see this part. So the air continues to go up and release to the atmosphere, and all the water slides down, and only the water goes into the growing, or most of the water, which is also very rich with oxygen because they were mixing together, goes into the growing bed. So now we were able to get rid of the pulsatile phenomenon. So it's less burpy. It's more fluent and continuous.
Okay. Matt has a question. It's, would diverting the air release back to the fish tank help with the noise issue?
You talk about, can you repeat? Which was the question?
Would diverting the air released back, basically putting it back to the fish tank, would that help reduce some of the noise from the burp?
Oh, you can try to do that, but we already developed a really nice muffler, like what do you call it? A system where we can put, or we take basically like a 2-inch pipe and we make slits in it, and then we put it at the top, and we put around it another pipe, plastic pipe, PVC pipe, and it appears that it works like a really good muffler, and you can eliminate all the noise. And I'm gonna put the picture of it on the Aquaculture Hub and on my Nest Talk, and make sure that also you guys instruction how to actually build it. As I said, I just wanted to go out with this webinar in order to give you some inspiration and to tell you guys, forget about the water pumps, because water pumps, you need to maintain a lot of maintenance. They are in the water, and eventually the sand and whatever comes in grind them up, and you have to throw them away or replace them or fix them. And the other thing is, when we work in education system and we work with a lot of kids, we want to make sure there's no electricity in the water whatsoever. And so we have an air pump, which is kind of, you can put it a little bit away from the whole system, so there's no electricity in the area, and all you have is a garden hose with a pipe, with the air. The other thing is, nobody can steal from you electric pump, or if it's water or air, because as Lole from American Samoa, she likes to have her air pump next to her TV, and not in the outside where's the fish tank. And still, she runs beautiful aquaponics system, and her taro is something really good and beautiful and very tasty.
Oh, thank you. One more question. Do I need to use a T at the point where the air and water mix, or can I use an elbow?
Well, I think that if you want to use an elbow, you have to realize that, let me take you back. This is an important picture that I think related to this, to your question. And I think that the schematic one where not this one, this one. This is an important thing. You see, what they did here, this is like the basic Airlift pump, right? So they came with an elbow. But actually, even you come with an elbow, it eventually is some sort of a T, because you need to start collecting the water from the bottom that coming into the big pipe where's the water, and then you introduce, if you can see number 5 and number 6 here in this picture, you introduce the air bubbles into the main pipe. And so you can either do it in a T, or you can come inside with the elbow, or you can, another way you can do it is just take the whole thing where you see the number 5 and slide it all the way down where you see the tip of the arrow of number 7. So you can introduce the air bubbles over there too. But there's some advantages and disadvantages to it. But I think the best for you to do is to experiment with it and see what is best for your system.
Okay, I think. Can you explain the water trap again?
Yes, I'll be happy to explain it. Let me go back to the pictures, and I'll show you what I mean. It's, I know you have to use a little bit imagination. Okay, this is an important picture for you to look at, because you see a 1-inch pipe coming inside a 2-inch T. Now what we do, do I have a pointer that I can show? Can I use a pointer here? Oh yeah, that's a pointer, right? Pointer, let's see. Can you see this pointer?
It should say it's up at the
here,
top right.
Moving forward. Can you see
you got it. You got
Everybody see it?
Yes.
Okay. So you see here the 1-inch pipe coming into a T. So what you don't see is that this pipe is coming up all the way here. It goes all the way to this area. Or you can take it even up to here. As long as it doesn't block, you can take it as high as you can without blocking the way. And what happened is the water and the air mixture going to go into here. The air will, most of the air will continue up, and the water wants to come down, but it will fall in this area, the trap, because here it's going to be blocked. The water cannot go back, and so it goes and slide into here. Again, you continue and you block. You can put here either a 1-inch or you can put even a 3/4 pipe coming inside into the T. So you have like double walls on the side, which will not allow the water to slide directly in, and they will accumulate and eventually going to slide into here. Does it make sense to you?
Hopefully. Yeah, he says he's understanding it now. John is looking at your air pumps, and he says, all the air pumps I see don't have fittings for a garden hose. Are you using an adapter, or is he just looking at the wrong pump?
Bingo. Bingo. I have a picture, but I wasn't able to put it on present, so it's becoming too big. But I'm going to show on Aquaculture Hub exactly the fitting, and I will show you how we do it. So basically, we take the original fitting from the pump, we put a special fitting that we put a bend to it with the garden hose and with the garden hose fitting. So the beautiful thing about it, from that moment on, you can do it in the middle of the night, in the darkness. You don't need to see anything. You just take a garden hose, you go there and you put the two fitting together, and it works magic. So yes, we do that. We use, yeah, I see here, horsepower. We use only a pump that we bought from Aquatic Ecosystem that has 38, or, we go all the way up to 60 watts. So whatever come, it could be maybe a quarter, but it's really simple pump that takes, when you think about it, you can use your aquaponics system with a pump that takes less than a light bulb. And that's the beauty of it. Not many systems with water pump can run a whole system with the amount of money that costs to run a simple light bulb.
Okay. One more person is typing, but I think we might have all our questions in. I know we're getting down to our time limit. But I would like to thank our technical team, Lisa, Deanne, for getting us up, even if it took a while, for getting everything up. I'm really grateful to them. And thank you so much, Benny, for, one more question. What about pump redundancies?
Well, sometimes some people can use even 2 pumps, if that's what you mean. And I can show you an example that I found actually in, let me see where, well, I'm not on my Chrome, but I have some great examples that I found. Actually, this was in Spain. Somebody was using a whole pond with koi with a series of small, air pumps that he put them next to each other, and he was running a whole big pond, including running it through a biofilter, with the macaronis kind of stuff. And I will put all of this information on Aquaculture Hub so you can go watch the movie. And the guy actually even allow you to download the movie. Fascinating things, how people use several pumps together.
That's great. Everybody's just saying thank you. Again, thank you so much. We are going to have to talk about when the next one's going to be. Hopefully it'll be soon. I'd also like to thank Barbara McLean for putting up all the links to Aquaculture Hub and some of the videos and stuff. As Benny talked, she was tossing up some of those links for us. So thank you so much. Thank everyone for being so patient and attending. I would really appreciate it if we will have this survey. that we are conducting to determine what kind of things you guys want to hear from us about and the value of this webinar. It helps us justify doing this again. So please, the link is up in the chat box. You may be getting an email about it as well, because if I don't get a lot of responses, I will email out reminders. So please go and fill that out, and we'll be emailing you with another, with recordings and information about the next webinar soon. Thank you, everyone.
Thank you.